Have you ever wondered about this? 13.8 billion years ago, the Big Bang created the entire universe. But the question is, what was there before it exploded? Was it pitch black, a vacuum, or nothing at all? Today, I am going to tell you a truth 99% of people do not know. The Big Bang was never the beginning. Scientists have studied this for almost 100 years and finally discovered that before that cosmic nuclear explosion, there was something 10,000 times stranger than you can imagine. In this episode, I will take you to see the deepest truth humanity can currently touch. First, a question for you. What is empty? You might say, if you suck all the air out of a box, is it not empty? Wrong. Absolutely wrong. Physicists did this experiment. They removed everything from a container and dropped the temperature close to absolute zero. Theoretically, there should be nothing left, right? But they found that something inside was still moving. Scientists call this a quantum vacuum. It sounds high level, but in plain English, it is the universe's foundational code that does not allow the state of empty to exist. You can remove matter, you can drop the temperature to the minimum, but you can never make a piece of space truly quiet. It shakes by itself. This is not an instrument error or a measurement mistake. This is nature's rule. The Heisenberg Uncertainty Principle states you cannot know both energy and time precisely at the same time. The shorter the time interval, the more violent the energy fluctuation. So, for extremely brief instants, energy can fluctuate wildly. What does this mean? It means the vacuum is not empty at all. The empty space you imagine, every cubic centimeter of it, is actually undergoing trillions of particle creation and annihilation events. An electron and a positron suddenly appear, exist for less than a trillionth of a second, then collide, vanish, and the energy returns. This happens around you every single moment. You just cannot see it. Because scientists found that this never-quiet quantum vacuum is not just shaking. It has weight, it bends space, and it is pushing the entire universe to accelerate its expansion. In 1998, two teams of astronomers observed distant supernovae, initially expecting to see the universe's expansion slow down. But when the data came out, everyone was stunned. The universe was not slowing down. It was accelerating, getting faster and faster, pushing galaxies outward. What is this force? It is the energy hidden in this supposedly empty vacuum. Scientists named it dark energy, and it accounts for 68% of the entire universe's energy. You heard that right. Over 2/3 of the universe is contributed by empty. Now you should understand that the empty we are discussing is completely different from what you imagined. It has energy, pressure, it can push galaxies, and it decides the fate of the universe. So, the question is, if empty is not truly empty, what could the state before the Big Bang have been? Here is a mind-bending fact. The Big Bang was not the beginning, it was a transition. Like water boiling into steam, the water did not vanish and steam suddenly appear, but one state transitioned into another. The Big Bang is the same. Before that hot, dense fireball appeared, the universe was cold, empty, and contained only vacuum energy, which made space expand at a speed faster than light. Physical laws state objects cannot exceed the speed of light, but space itself can. Imagine you are blowing up a balloon with two dots drawn on its surface. The faster you blow, the faster the dots move away from each other. If you blow fast enough, the distance between the two dots can increase faster than light, but the dots themselves are not moving. The early universe expanded exactly this way. Scientists call this inflation. In about 10 to the negative 35 seconds, the universe expanded by at least 10 to the 26th power. Something smaller than an atom instantly became larger than the present observable universe. You might ask, what force could possibly accomplish this? The answer is that never-quiet vacuum energy. The universe during inflation was dominated by a special type of vacuum energy. This energy has a strange property. It generates repulsive force, not attractive gravity. The more normal matter there is, the stronger the gravity. But with this vacuum energy, the more space expands, the more of this energy appears, and the greater the pushing force. This is a positive feedback loop, an uncontrolled exponential growth. Then this energy driving inflation suddenly decayed, like a spring wound too tightly snapping. All the energy was released at once, turning into particles, radiation, and heat. This was the Big Bang. What you previously thought was the bang of the universe's birth was actually just the aftershock of inflation ending. The universe was truly shaped by the previous stage, the cold, empty, but madly expanding phase. I know what you are thinking. Does this not just push the question further back? Before the Big Bang there was inflation. But what was before inflation? Great question. Humanity currently has several theories, each one shocking enough to keep you stunned for days. The first is called quantum tunneling. Remember, the quantum vacuum is always shaking? Scientists calculated that if the shaking is violent enough, there is an extremely small probability that a universe could tunnel out directly. Like a prisoner constantly hitting a wall, classical physics says they can never escape, but quantum mechanics says if they hit enough times, they will eventually tunnel right through. The universe may have come into existence this way. A tiny fluctuation in a field of quantum foam accidentally grew up, becoming inflation, the Big Bang, and then us. A startling implication of this theory is that we might be just one bubble in an infinite multiverse, where each bubble has its own Big Bang, its own physical constants, and its own history. Most of the bubbles are likely dead, with physical laws that do not allow the formation of atoms or stars, nothing. But occasionally, one bubble has the conditions just right, leading to galaxies, planets, life, and a figure of the viewer. The second theory is wilder, the Big Bounce. It means the universe did not come from nothing but from the death of another universe. Imagine a universe that expands to its limit and starts to contract, getting smaller and denser, seemingly about to be crushed into a single point. But at the last moment, quantum effects intervene. The discrete structure of space itself prevents it from shrinking infinitely, so it bounces back, contraction turns into expansion, and the death of the old universe becomes the birth of the new. Our Big Bang may just be the final sigh of a dying universe. The most chilling part of this theory is that the bounce could continue forever. Expand, contract, bounce, expand, contract, bounce, infinite loop. The universe was not created. It has always been here, constantly changing skins. The stars and matter you see today might have come from the last universe, and the matter of the last universe might have come from the one before that. This chain might have no first link at all. The third theory is more science fiction, brane collision. The theory suggests our universe might be a brane, a membrane, floating in a higher dimensional space, like a piece of paper floating in a three-dimensional room. In this room, there might be another brane. The two brands are slowly pulled together by some force, and then they collide. The energy released from the collision is the Big Bang. After the collision, the two brands separate, each evolving its own universe. After enough time, they are pulled back to collide again. Each collision is a Big Bang. Each separation is an era of cosmic history. Hearing this, you might be saying, wait, this is too esoteric. Is there any proof? There is, and the evidence is right up in the sky. Scientists found that the cosmic microwave background, CMB, radiation is the afterglow of the Big Bang, and it hides things that should not exist. Logically, different parts of the universe should have evolved independently during the Big Bang. Regions too far apart had no time to exchange information. But measurements show that the temperature of regions separated by tens of billions of light-years on opposite sides of the sky are almost identical, with an error of only a few parts in 100,000. How is this possible? They had no way to coordinate, so how can they be so uniform? The only explanation is that they were once together before the Big Bang. Before inflation, These regions were small enough to touch and equalize. Then, inflation stretched them to the opposite ends of the universe, but that early uniformity was preserved. This is why scientists say the Big Bang was not the beginning. The beginning was that earlier, cold, empty, but communicative state. There is another, more direct piece of evidence. The temperature fluctuations in the CMB fit a very specific mathematical pattern. This pattern can only be produced in one scenario. Quantum fluctuations stretched to cosmic scale. During inflation, those tiny jitters in the quantum vacuum were forcefully pulled apart by exponential expansion, becoming the seeds of the universe's large-scale structure. The clusters of galaxies, superclusters, and the cosmic web structure you see today are ultimately magnified versions of those quantum jitters. So, we are not just guessing. We have solid astronomical data supporting these theories. But here is a question that drives all physicists crazy. What is time itself? When did it begin? This question is more mind-boggling than what was before the Big Bang, because the word before itself assumes time already existed. If time was born with the universe, then asking what was before the universe is like asking what is north of the North Pole. The question itself may be wrong. Hawking and Hartle suggested an idea. Perhaps the universe has no before. Time, in the early stages, was curved, turning back on itself to form a closed sphere. Just as the Earth's surface has no boundary, there is no concept of south of the South Pole. The universe might be finite in time, but it has no edge, no beginning, and no before. But other physicists disagree. They say the moment of quantum tunneling was the moment time was born. Before tunneling, it was not that time did not exist, but there was a quantum state that did not reside in our familiar spacetime, but existed in an abstract mathematical space. You can say that state preceded our universe, but not in a temporal sense, but in a logical, causal sense. This sounds like wordplay, right? But this is what the cutting edge of cosmology looks like. Our language was designed for everyday life, not for describing the end of spacetime. Now, let me summarize humanity's current understanding of this problem. The Big Bang was not creation, it was a transition. Before it, some state existed. Perhaps the vacuum of inflation, perhaps the contraction before a bounce. The universe might have been a fluctuation in quantum foam, or a collision between two brands. Regardless of the theory, it was not nothing, because physics tells us that true nothing cannot exist. Quantum mechanics does not allow absolute void. The uncertainty principle ensures the vacuum is always shaking and energy is always fluctuating. Empty is a real existence with properties, structure, energy, and the ability to affect the motion of matter. So, what is the final answer? Before the Big Bang there was not a void, but something that exists, something we cannot name, see, or touch. It might be eternal, always there, simply changing its manifestation. Sometimes cold vacuum, sometimes hot fireball, sometimes expanding, sometimes contracting, cyclical, with no beginning and no end. You exist right now in a small window of this eternal change. A transition 13 billion years ago created the conditions that allowed you to exist. One day, this phase will end, but the universe will continue, just in a different form. We did not come from nothing, and we will not go to nothing. We are a part of this eternal dance, just coincidentally conscious enough to ask these questions. This may be the most magnificent answer humanity can conceive. The universe was not created. It has always been changing. Change is its essence. Existence is its default state, and nothingness has never existed and may never exist. This is the truth of what was before the Big Bang. Not an empty void, not darkness, but an eternal, non-stop quantum rave.